In this video, we'll talk about digital input. Last video, we talked about digital output. So now we talk about input. Let's go. How to connect a switch and the push button. Alright, let's talk about it. Connect a switch, you can connect in terms of VDD and VSS. This is the positive, this is the negative. You can connect there, high. Then if you go here, it's 0. So it's 1 and 0 and that's it. But it's not used. Why? For several reasons. 3 terminals instead of 2. Why do you say so? There is 1 terminal, 2 terminal, 3 terminal over here. Ta-da! Needs 2 or 3 wires because there is 1 wire, 2 wire, 3 wire to your output. Something like that. The most trouble thing is floating. What is floating? It's when you are not connected to VDD or VSS. Alright, so you are just halfway hanging on the streets. You don't know what to do, and that sucks, right? So you're floating there, and this floating actually cause what? Cause possible severe problems and very difficult to isolate the problem itself. Alright, and therefore this switch is actually very troublesome. When we want VDD, we want VDD. When we want VSS, we want VSS. We want something that is in between that actually cause troubles and things like that. Okay, and therefore what do? Use a pull-out resistor. A pull-out resistor is approximately about 10 kilo ohm. Alright, and it's often connected to VDD. Alright, when you're talking about connected always to VDD, what do we mean about it? Talking about active low. Alright, because it's always connected to the VDD supply. Always blam, boom, 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 blam. Active low means that you're always on. Alright, always on. If let's say your LED is here, always on. And then when you close the switch, bam, this is the grounded switch. When you close the switch, it actually off. Alright, because you ground everything. Ground everything means that the whole switch is actually gone. And that's it. This is just the pull-up resistor purpose. And therefore you only have one switch over here, simple switch with a push button we call it. Alright. And therefore comparatively to the old one, you see there is 3 port 1, 2 and 3. So three stuff, which is walao, right? And therefore let's go. And then we also have only needed one wire straight down, and that's it. Alright. The wire is actually going in this direction. The ground is actually connected to something else, alright, because the ground connections can usually be found nearby. Alright, I don't know where is the nearby coming from. Yeah, the input is always connected to something, so therefore you can always supply your input. But however, if your switch is closed, then there is a waste of stuff, right? Because all your VDD supply, alright, all gonna go to the ground, and therefore it's just all grounded. You're just wasting your stuff, alright. You're just wasting your current or voltage, I would say. Therefore, this was in fact off first, alright. The switch was kind of like open circuit. So when you close already, you press this button, you will close the switch. When you close the switch already, all the VDD will go to here. Alright, you will not go to the microcontroller, and this is just what it is trying to say. So you pull out the resistor. I think for the pull down, in this case, pull down means that you're gonna close the switch when you press the button for the VDD, your supply. When you close the button, this means that the flow will actually flow to wherever you want. Alright, and therefore maybe the bulb will light up, things like that. Alright, so the pull down and pull up is just the meaning. Pull up is simply when you connect the switch to the ground. Alright, pull down means that you're gonna connect the switch to the VDD. Alright, so yeah, and pull down is active high. Alright, it's because when you apply the supply already, when you close the switch, alright, it will become high, and therefore it will become active, and that's all it is. Alright, in Arduino we often use pull-up resistor, and that's it. Alright, so pull-up is I mean pull-up resistor. For Arduino always use pull-up. So pull-down we actually somewhat didn't use. Alright, we can read how it works, but I'll not go through with it because I'll just explain. So how much current is being wasted, because we say that for the pull-up, alright, if let's say your switch is closed, alright, all the VSS is gonna go into the input. So your input is actually grounded, and therefore there's no input at all. Alright, so all your VDD we're gonna go through the resistors and go to the ground also. Alright, so there will be a wasted current flow through the pull-up resistors from the VDD to ground. That's just the meaning of that. So typical supply voltage is 3 volt from the Arduino, and the pull-up resistor is often 50 kilo ohm. So how much current is wasted through the pull-up when the button is pressed? So it's talking about pull-up, which is what we have been saying all along. And how does it compare with the operating current of the microcontroller? So the operating current of the microcontroller is actually 3 milliampere. Alright, just use V equals to IR. Alright, our system Arduino has 3 volt, and then our so-called the resistors has a 50,000 ohm. Alright, so I'll just take 3 divided by 50,000. What I have is 0.06 million ampere. Alright, comparatively to your operating current of a microcontroller for each pin, alright, this 0.06 is like a mile. Alright, so it's like really damn small. So therefore, okay, never mind, it's cool. Reason behind why we use pull up rather than pull down is because it's easier to find a connection to ground near the switch. Why? You see the ground is here, the switch is over here. So it's easier to connect the switch and the ground together. So normally the switch and the ground are connected near to each other, I would believe. And therefore this is why they use that one. Maybe because, as we said earlier, because this is the ground, right? So there is so many pins over here. So these pins are all the so-called the inputs. Alright, so all the switches can be somewhat near to the ground. Then I don't know, just leave you to think about it. At least something for you to see, like nice only macam. Let's talk about internal pull-up resistors. Internal pull-up resistors is just simply pull-up resistors, but put inside the internally of the microcontroller. Alright, inside the controller, as you can see, and then for most of the input-output lines. Alright, and which makes the circuit really simple. Alright, because it makes things easier to press. I don't know. The resistance is around 100 kilo ohm to save the current. Alright, for the internal pull-up. Alright, and the pull-ups can be turned on and off individually by using the pin mode function. So you have an Arduino system, then you just type in the code, and that is it. Alright, each of the button pin means that each of the pin, each of them are all pins. So each of them has actually their own internal resistors. Alright, not maybe the resistor itself, when you type in this code, the resistor will actually connect to the pin and somewhat initiate the function of a pull-up resistors internally within our microcontroller. The purpose is to save the current, because when you often this is the VDD, if you remember, if you were to send your signal all the way to VSS, if you on the switch, alright, this, although the input will although your stuff will actually keep doing, maybe you have a fan and the fan keep turning, alright, that's good. But however, there'll be a current that keep flowing to the ground. Alright, although it flows to the fan, but there is flowing to the ground. That's what I believe. No, it's an active low system. Active low means that when you connect, it's always connected to an input, so it's always like turning or things like that. And then suddenly when you close the switch, you somewhat off this input, and therefore all the VDD will go to the VSS, something of the sort. Alright, so it's an active low. Remember, it's an active low. When it is low, alright, when it's connected to the ground already, it becomes active. So yeah, that is the case. Last one is the switch bounce. What is this all about? When you have a signal over here, when you close, it will zoom, and then later on when you open, zoom out. This is the ideal case. But however, in the reliability case, alright, when you close, it zoom, and then when you want to open, and then I don't know macam. Trying to eliminate this little noises or this little bounce. Alright, but what makes this bounce so irritating is because ideally is this one. This is really good. Alright, if let's say I have something like this, when you want to close, it zoom. Alright, this particular zoom out, alright, because of this bounce, it actually causes your system to read that, okay, now since you are high up again, let's continue to be high, although you are actually close. Alright, because when you want to close, the bounce will actually sometimes like this, and then it will close down. Should be fine. This bounce is still okay. But however, sometimes when you bounce, the system may actually read, okay, so let me continue, and it just keep going. Alright, so it didn't actually close, and this may actually give a certain problem, and therefore this is why we want to eliminate the bounce. And this can be typically last for about 50 microseconds, and one way is to do extra components, or normally you will use a software to cause a delay, because this bounce, as you know, once you close, you wait maybe some sort of a some milliseconds, alright, and then you'll just close normally, and that's it. Right, instead, so this part over here is a delay, so you know that you close already. Once you close, it's at this point, alright, but the system will say that, okay, delay first, alright. The system will close itself, and then once the delay is really settled down already, when it's safe, then you let it go. Alright, let it go. Yeah, these are the things that we're talking about, the outputs and the inputs. Alright, just let them know that pull up is active low and pull down is active high, and know that when it's low, it means it's going to be active. When it is high, then it's going to be active. So when it is low, then it will become active. So this is active low. Alright, so when it's 0, you're on the light, something like that. Then when it's 1 or high, you're on the light. So it depends. So active low, just remember, if it's pull up, active low. If it's pull down, active high. So it's just about it. This down, this is high. This is low, this is up. Something like that. And we have also internal pull up resistors. Alright, and so far so good. And the little stuff are the decoupling is the capacitor is to reduce the noise, electrical noise, and to protect your components. ODT is to minimize the distortion of the signal. And further up, the PCB track allows you to have a impedance prevention for the signal reflection, so that you can actually this impedance will be the same as the ODT. If it's not the same, it will not generate an output. Alright, so it's somewhat like a gate to a certain extent. Lastly, the switch bounce, you can actually prevent the switch bounce by causing a delay, as we have mentioned earlier. Alright, these are the little stuff, and I think that I felt that it's kind of important, and these are all the stuff that, yeah. So see you soon.